Hello, welcome to the stream. Happy Sunday. Today, I wanted to do something really ambitious because I kind of got the hankering to do it in the middle of the week this past week. And so I poked at it a little bit in my free time. And, last time we made those demos, we made the B-spline demo that's like a fly through, like the camera is always looking at the same spot, but it's like flying through the scene. That's pretty cool. With the help of Renatias. Hello, welcome to the stream. We made the box follow a path. That was pretty fun, which was a Catmull ROM curve. And maybe it's like my background having worked on Fable, which incidentally, because this laptop I inherited from that job when the company ended, will still show up in my browser history. But we're gonna try to do a Bezier editor today. So Bezier curves, cubic Bezier curves. I think the challenge, there's multiple challenges with this, and most of them are not related to drawing the curve. They're more about what are the interactions to create it. So I want to go really simple first. I think that what we'll do is we'll just have you click on the canvas to add points. So as you add points, we'll draw the curve. And I think that'll be a good first pass. But what I'd really like to do is and I have the code kind of stubbed out right now, I'd really like for you to be able to select a point that's already there, right? There's some other unrelated questions or like quasi-related questions that we probably need to solve as well. Again, we're not trying to make a like you would draw like you're going to replace your SVG editor with this. No. I just want to show how you could use a Bezier spline in a real app. So so we need to solve a couple of unrelated things. The new API for Tiramisu is wonderful, but a lot of things got dropped. Hello, Nanaba. Welcome to the stream. I think that's Nanaba. Hi. Okay, so we don't have line segments anymore, at least not directly. We don't have debug circles, like any of those like debug primitives that were in older versions of Tiramisu are no longer there. So we kind of have to create something for that. And like we got around it in the other two demos because we didn't need to show the curve. We just needed to operate through the curve. But since this is a editor, we need to actually draw the curves themselves, right? So we're going to have to solve that first of all. And vec2.signed angle tomorrow. Woohoo! Sound stuffs is gone to sound. Oh, from Tiramisu. Yeah. That's okay. There's actually really good sound APIs in the browser. So I was looking at during the week. Let me show you first of all where I am. We have basically nothing yet, but let me flip scenes here. Okay, so I've got the stub here. Basically, we're going to track the canvas size because we're going to need to map the size of the canvas to the world space, right? And so we're going to have to do some transformation there. That's interesting. The idea here, though, is pretty simple. We're going to collect a list of points as the user clicks around on the canvas, right? We will have, like, when they click, we map it down, or we map it into world space. I put, you can see here, selected and a mouse down. These are in preparation for doing some more advanced things, but I think that if we initially add the point, we set the selected index into the list, and mouse down, like when they initially click, then you could potentially do drag, which I think is really good. I call this mouse down, but I actually think I'm going to use the pointer, because we could potentially allow a touch interface, and the pointer events are more generic than just the mouse events. So let's see if we can rename that. No. Okay. So we're gonna say mouse down, and we're gonna replace that with pointer down. You can see I already changed this. And let's replace it in all places. Okay. Okay. And then we have a cached version of the spline. So when we reach 4, 7, 10, 13, etc. Points in the list, we can add another curve, and so that means that we should recompute. Basically, this is going to be something that we manage through the update function. So if something changes significantly, we kill the cache spline, like we reset it to none, and then on the next redraw, it'll recompute it. So as long as we're not changing the points, we shouldn't have to recompute it, right? So we're gonna rely on the update function to maintain that state. All right, right now we just have the tick, that's the redraw, as well as the refresh, the cache spline, and we have pointer move and pointer down. I thought about maybe because Luster creates really, you can see I'm digging in the source here. Luster has these, and these are great if you only care about tracking that the event happened, not that like it has any other information. So what we need to do is use this generic on function and provide a decoder, and that decoder can take things off of the mouse event. So that's why I have this, so the pointer event, like all these extra things. Pointer event inherits from mouse event. So we can look at mouse event to see what properties are in there, and we might want to take advantage of things like the keys that were held down, or that were down when it was fired. We might want to track like what button it is. There's we're gonna have to dig through this documentation to handle it carefully. But okay, so the main things that we want to be concerned with first are offset X and offset Y. So let's make a decoder. This is not the best place for it. Let's put it down at the bottom. We'll call this pointer event decoder, and it's going to return a decode.decoder. I'm going to have to import that. I did some learning this week as well. This I think I actually want to do Yay, editor. Hi, Chris. Welcome to the stream. Yeah, separate package for the rest of the nodes is the way. I agree with you, Renatus. Like, it's one thing to make something work. It's another thing to like set yourself up for future, future improvements and enhancements. And it's a really delicate line to walk because you want to show, hey, my thing is useful and powerful, but you also can pretty quickly get into, well, I've coupled these two things together, and now they're difficult to deal with. So I really do appreciate the direction you went, especially given that it kind of simplifies that luster tiramisu interaction. And so it's like, hey, I can just write some UI and then stick a canvas in it, and things just work the way you expect because all of those bits that are related to the drawing on the canvas are just custom elements. I think that's really brilliant. Okay, taking a step back. So we want to take, and here I actually think I want to take a, this is going to be a function because we're only really caring right now about the position. It's going to take and return a message. So what we want to do is we're going to and here's the bit where I'm not sure if it's going to work, but what I want to do is like pass just the constructors for those two messages here, and then we can say when we add the handler for like pointer down, pointer up, we pass it our pointer move and pointer down. We do need pointer up. Here we'll rename that. Here, let's rename that real quick. Mouse up. My cat is here licking my hand. Pointer up. And we don't actually care about the position, I don't think. We're just saying pointer down is false. Okay, then now I'm a little bit less confused. Okay, so we will do, this will take a message, or this will take, what we want to decode is this vec2f, right? I think I need to qualify that. Something's going on with my language server, and I'm not really certain what it is. So I think, based on things I've read before, right, right. So there's also this advanced business, which I don't care about not propagating. Like prevent default, stop propagation, I don't care about that. We'll just do on. And let's look at the implementation of this. So like here, this is what they do, right? So on blur would mean you like lost focus from the element. They're just calling this internal. It's not internal, it's exposed, but this on with the blur event, and the decoder is just success of that message. And that's why I felt like it's not appropriate for what we want to capture. Because if you look at on mouse down, it's like, hey, we're not decoding anything from that event. We're just saying it happened. And I think that we, same with all these other mouse events. So we want to do this custom event handler. I'm just gonna guess what we're working with here. And we can use the attributes of the mouse event here as a clue. We don't want client X, we want offset X. if you're not familiar with this use syntax, it's just turning nested callbacks into flat. So now we should be able to see. I need to restart the language server. It is not happy. Oh, it's not even running. Not even running. What? All right, let's restart, because I think that it was very unhappy. We're just not running the. Oh, okay, here we go. Okay, so these come out as ints, and I actually think that is correct, and I just got it wrong in here. So we need to change this to vec2i. Okay, so now we can say decode success m of vec2 xy. Right, so now we've got a decoder that will extract these two fields out of the mouse event, and we'll then stuff it into our, whatever function we pass. So I think the main thing, let me qualify that option.none. See, now it's finding all the bugs in my code. Okay, so now we can go in our view, and let's just make a really simple view. We're going to make a div, and we'll figure out what the classes are later that we need. I'm going to put a tiramisu scene in here, right? And this is going to be main scene. And let's do on, and we're going to do pointer down. And here's where we can use our pointer event decoder, because this takes, it's got to return a message, right? So let's do pointer event decoder, and we'll have it do pointer down. And we'll do the same on move, pointer move, and have it return pointer move. Okay, and then we'll say pointer up. And we just do pointer up. We don't have any extra stuff there. Okay, and this has no, let's import that. That's probably, yep, import luster event. Okay. Okay, so we'll just say decode success. Honestly, we could have done mouse up there, because the pointer events, they are more generic than the mouse events. We could have just done on mouse up, but it's okay. I want to be able to catch, if we open this on our phones or something, that we could get touch events as well. So, all right. So I think we need a little bit here of handling this. So for the pick function, so pointer down, and so we already did the move selected point function. I'll walk through that in a minute, and the cache spline. So for the pick, for right now, I want to say let's just console log position and just return model unmodified. So this is just to get us to show that those events are coming through correctly. There's some bits here. Maybe run a TS. Oh, the volume's too low? Really? I have it way up. Curve editor on the go. Yep. I mean, who doesn't need to edit Beziers from their phone? Yeah, I do. Don't you? Let me see if I can tweak that. I'm very sorry. It feels like every time I open OBS, something, I have literally not upgraded the software. Something changes. And it's like, what is this? All right. Sound. Okay, let's bump up the input volume a bit and tell me how that is. I feel like I'm speaking really loud too. But if that's better, let me know. If it is not, I will crank it all the way up. Oh, okay. Yeah, I mean, yeah. Like, I don't do any post processing. I just adjust the input levels. And like I'm looking at my OBS and it's all the way up on that channel. So whatever. Okay. Yeah, let's take a beat and look at what we've got in this file already. Okay, so we do the typical main function. We register the built-in extensions on Tiramisu. We might need to add our own. That would be fun. We create a Lustre application with our 3 functions in it, and we start that app. Okay, typical stuff. Nothing interesting there. We talked about the model already. We're tracking the size of the canvas. We're tracking the list of points that the user has created. We're tracking which one of those points is currently selected. We probably won't use this right away. We may just use it for, I'm currently moving the last point as I create things. We're tracking whether the pointer is down, so whether the touch event is active or whether the button is still depressed. And then we cache the spline. Our messages are tick, that's the refresh, the request animation frame message. We're moving the pointer, we press the pointer down or we let the pointer up. Okay, so those are the messages and the basic model. We initialize this with basically nothing selected, no points, and the canvas size is 0. And what I want to do is something along the lines of an on mount, but I need to figure that out. We may just set that to a static size to start. And because what I would love for it to be is like full screen, and then as you adjust the size of the screen, we update the canvas size. But I think that that's going to require some additional events. Like there might be a canvas size changed event, but I need to think a little bit harder about how to do that. Okay, so in our update function, this is the Elm architecture again is what we're working with. The tick event is our request animation frame event, and it's just making sure that the spline is cached, so when we go to draw the view, that we have the whole data structure containing the spline, and there's no extra effect. This tick happens automatically unless you unsubscribe. And notice we did here in our init, our output effect from the init is subscribe to the main scene for our tick message. Okay, so as long as this element with the ID main scene is on the screen, we'll get tick events. Okay, pointer move. We're choosing to, if the pointer is down, so like we previously got a pointer down message, then we'll move the selected point, which doesn't really do much yet. We'll have a look at that. But for the if it's not down, then we don't do anything. Like we don't care. We ignore that event, right? Okay. If the pointer is down, then we pick. And by picking, this usually means we've got the 2D representation of the scene. When I say 2D, I mean it's like we're talking about pixels, right? I'm not talking about, oh, this is a 2D scene, which we'll be doing. We'll be doing a 2D scene. But what I mean is we need to translate the pixel on screen to a position in the game world or the visualization world. That's what the pick function is supposed to do. And the output of that will be maybe we selected a point, maybe we inserted a point, and that new point is currently selected. And then then we will change the game model or the simulation model, the edited model from that pick function. And there's no extra effect. We don't need to do anything extra there. And the pointer up is just like, hey, the pointer's no longer down. Now, the pick will also have to handle, do we already have something selected? And are we potentially? I may choose not to do this for the first round. Probably not. But in this case, if it's already selected and we have a new down event, we need to see, is it close enough to the selected thing? If it's not close enough to the selected thing, then we need to create a new point, right? That's what a pick function would have to deal with. So it's a kind of a little state machine. It's a little complicated. All right. So what I want to do now is just let's we need this screen to world, and I think that I need to implement that function. The other option is that we use orthographic, and we don't track the canvas size. And this is just an integer version of the float position. The thing is, though, we would still have to translate because that XY is like from top left. But our world camera is probably going to be 0 zeros in the center, right? So maybe what we'll do there is just do, let's go ahead and make this function, and we'll use the LSP to generate that. Okay, so we've got the canvas size. It's an int. We got the position. So at the very least, we need to get what 1/4 of the screen is. So if I guess transformation would be easiest to do with a matrix. All right, let's just draw a little picture here. So our screen is like, something like this, right? And we'll just pretend that there's, this is the middle. Oh, that's bad. Let's make it odd. Okay, ASCII diagrams for the win. And let's put a plus there, and let's duplicate that. Okay, so now we've got, this is our canvas. And in screen space, this is 0, 0. And this is, canvas size over here, right? But what we want is that middle bit to be 0, 0. So yeah, if we just assume that the world space is the same units as the screen space, that'll make certain things easier. So this is going to be up here. This is going to be negative canvas size not x divided by 2, and this is going to be canvas size dot y divided by 2. And down here, this corner, gosh, that's got too wide. This corner is going to be canvas size dot x divided by 2, and canvas size dot y divided by 2, negative canvas size. Okay, so we need to make that transformation happen. So assuming that we have something that tracks the canvas size, that's fine. And I need to make that a little plus because that's where the axes cross. Oops. Okay, so to make this transformation happen, let's go ahead and get these first into a float. So we're going to map canvas size with int to float on each dimension. And let's do the same float position. Okay. So now we're in float coordinates, which is what we want. Okay, so I think the simple answer is we need to subtract 1/2 extent of x, right? So so the x is going to be float position.x, and there's probably a way to do this better, but I'm going to say float size dot x divided by 2, right? Okay, I just want to satisfy the compiler there for a second. So this is basically saying you're half as far across as you were, and so we've shifted the whole world space to the left, right? Okay, but for the y, it's actually you're inverted. So these are, in the upper half, it's all 0 to canvas size over 2, but inverted. So we need to do the top half is canvas size over 2, canvas size y over 2, subtracted from the y value, and I think that's just the answer. So not subtracted from the y value, but the y minus the y value. So we'll say float size dot y divided by 2 minus float position dot y, and I think that I need minus dot. I think that's the answer. So let's think about it. So if this is this is 0 up here, and this canvas size is 100 by 100. So from 0 to 50, we should say this is 50. So if y, the position is 0, then it'll be 50. If so this would be 50 here, so it should be 0. And then down here it's 100, so 50 minus 100 is negative 50, right? So I think we got that computation correct. There is a more elegant way to do this. I just wanted to think through it really carefully. So I'm going to put a note up here that for now we directly translate pixels into, we're going to say TL pixels into center world space in a 1-to-1 ratio. Okay. Okay, so I think that we've got something sufficient for that. I would rather have a more abstract world space. Then we can play with things like zoom and so forth. But for now, this will be our screen to world function. Now, the main problem here, though, is if our canvas size is 0, that's going to end badly. Right? Well, we don't have it in the denominator anywhere. It's just not going to make any difference. This will be, position minus 0 or 0 minus position. It's not going to make any sense. Okay, that's fine. We will fix that. So let's let's see what we can do. And I think I was looking at maybe the window, but there might be individual events. Web APIs. Is it DOM? Maybe it's the DOM API. I think what I want to see is error event before on load event. Let's look at all the events that are possible in here. I want to say there's like a, because we could look at window resize event. I really think we're probably going to have to go pretty low level to get this information, and we might just be better off setting the actual size of the canvas for now. Let's just search resize events. Okay, so that's on the window, which I did pull in plinth so that we can add these raw event handlers to the window if we need to. The issue is I want to go find the element. Yeah, okay, I think for now, let's just pretend. We're going to say vec2.splat, and let's make it 600 by 600. Or no, I don't need splat there. Let's just do that. Okay, just one. And then let's make the scene that size. Where'd our view function go? Okay, so width 600, height attribute dot height. There we go. Okay. And the reason I want to do this for now is that I would like to, in addition to having this scene in view, I would like to have some UI widgets on the side, like the list of the points would be really great. You know, either as a table or something like that. And maybe we can go ahead and do that. Let's make use of the model here. Kind of need to make some classes here. We're going to show flex. Let's go ahead and make a new file here, Beziér editor.css, and we will do basically this business. Okay, so I have to remind myself of maybe we can just copy something from something else. Did I do much in here? Yeah, flex column. So we want to flex in the column direction. We'll just copy that business. And sure. Okay, fine. We'll just use those for now. Here we're going to have to, we need to handle the tailwind. Oh, okay. Come on, kitty. Thank you. She likes to get up and down while I'm working here. Okay, so we've got flex. I think that right. Right, so we'll use flex auto on here. I don't know that we need... right, so flex none keeps it at its standard width in a columnar layout. And these are, I think it's sort of like you add them up and those are proportional. Yeah, and I think, so this is taking into account the width. Right, so if we shrink it, you know, it's kind of proportional. Yeah, I think we either want flex none. I think we want flex none on there. That'll mean it won't change with the window size change. Right, prevent it from growing and shrinking. So in this case, only that grows and shrinks. I think that's what we want. Okay, and then we're gonna do, let's do another div. And this is gonna be sort of like our right column. And I think we probably want a gap here. Gap. Right, so we need, let's put gap 2 on the parent container. That should be enough. And let's not put a border, but let's do a different background. Background black on this thing. And then for now, I think let's just do a... Let's map over the model points. Let's make this, so this is, let's do flex 1. Let's change this not to a div, but to a UL. And I think that we will do, this is actually an OL, ordered list. And let's do list style type none. Right? We don't actually, I'm just using semantic HTML here. We don't actually need to display anything. Okay. And then what we want to do here is make a for each item we want to generate you know, what is the point in there. I'm just, you know, we don't have to do this right now because I do want to get to the point where we're actually showing something on screen. But this will help when we go to start debugging pointer events. Okay. So if this is a point, what do we want to generate? We want to generate a list item. We'll put no attributes on it for now. And we're going to do text p.x, except we need to limit the precision on this. What can we do? I don't want to truncate. Oh, but here's the thing. As long as we're in screen space, it doesn't actually matter. So we can... there's 2 precision. Yeah, let's just do let's just give it 1 and float 2 string, right? And then we'll do that, and we'll do the same with y. Easy enough. Okay, so we can display a list of the points that are in the model over on the right hand side. Okay, let's get this going. Luster dev start and see what happens. Probably going to be told I'm completely wrong. Why is it taking so long to download Tailwind? Okay. Okay, so let's have a look. All right, and we're going to look at the contents here. So, tiramisu scene. Interestingly, like, that is... I think I need to throw something in here. What is this background gray 950? I mean, the interesting thing here is this is it not taking up the whole thing? Okay, so we're getting the width on there. Obviously, it's filled with a dark color, so we can't really see what's going on there. Let's, but this OL, yeah, it has no contents, and so yeah, this is not getting. I guess it's just flex none is the only thing on that. Okay. Anyway, let's go to the console, and I want to see we're not. I'm clicking on the canvas, right? We should be logging. Yeah, let's just not bother with that for right now. We should be logging the places that we clicked. So let's do console log here, x, y as well. Okay, so it's just 0, 0. There was one of them though. It's 0, 166. Okay, so we're getting. That is interesting. Okay, so we are getting those mouse move events. I want to do this, and we'll say console.debug message, and we'll throw that in there. Let's clear the console. There's a bunch hidden here. Let's verbose. Okay, so we've got pointer move, but it's just 0. So I think that, did we get a pointer down message? There's our pointer down message. Okay, so I think that we're not getting the correct information out of the mouse event. And I think that we need to deal with that. I may be misusing that bit. So let's look at the. We're gonna go back to the pointer event. Pointer events. Okay. So this, this inherits from mouse event. So we could get the viewport coordinates. We could put that in our decoder and just like print them out. Relative to the document, relative to the screen. That's an alias for client X and client Y. So let's decode that as well. I think it's just a question of what is the appropriate one to use, and maybe this is where we're going to leave that. And then the decoder returns, okay. Oh, is it that, what are you saying, Renatius? I just see, and the decoder returns 0 and fails. How did you notice that? Is it that this needs to be a float? A double floating point value in pixels. Okay. Well, then let's go ahead and say yeah, okay. So let's do float. So it just returns 0, right? So let me comment. We'll go ahead and capture those. Okay, so let's do float. Truncate. Let's just do that for now. All right. Thank you for calling that out. I for some reason thought, oh, this is surely integer, but like if there's just a little bit of, let's see if that pans out. Okay, we're gonna clear the console. Okay. You were right. You were right. Okay, so really then, I think maybe what we do is we just now this is debugging client X and client Y. Let's console debug message as well. Okay, so here we're actually getting, I probably want to do round and not truncate. Yeah. Should be float. I just took a code. Okay. Thank you, Robert. Welcome to the stream, by the way. Thank you for jumping in there. Okay, so I don't think we need client X and client Y. The offset is fine. But I'm going to go back up to here. Actually, we need to change this. Let's change this and break everything. It's fine. It's fine. Okay. Okay, so now we just need to change these. messages. So this is going to be just a vec2f and vec2f. And then, so we'll need to go to that, and this is and here in the screen to world, we don't need to do this because this is going to be a float, right? And so we'll just do position. Yeah, I know. There's one more, and that's the pick function, and this needs to be f. Okay. Break it all, rewrite it from scratch. Yeah, totally. I didn't check, but is this? Yeah, this is that commit. I probably need to update to the latest. I just didn't want to float on main and go, oh, all of a sudden it's broken. Yep. We'll go back and update that later. I want to get further down the road. Okay, so let's clear this out. So there I've got that's the pick function, right? It's just logging the position. So I'm curious if now would be to redo one of the things I've been doing in terms of using Gleam Paint right now. It's also great though. Oh yeah, Paint is great if you just want to programmatically draw things. I'm just using Tiramisu because Tiramisu is cool. Okay, so pick, and you notice that when my mouse is down, it's not doing anything. So this is the only time the pick function really fires is when the pointer goes down. It doesn't fire when the pointer is moving and the pointer is already down. So let's make our pick function actually do something, which is really actually kind of interesting. So for our first version, we will not allow you to select a point. You can only create new points, right? So we're going to, and here's some things that are kind of funky that we need to think about. It's gonna be really bad to add the points to the end. So we probably need some kind of queue that's easily reversible, and we could, you know, flip it around. Which might mean we want to, well, let's, forget it. Let's just do it the hard way. So what we're going to do is we are going to take the points. So we're going to make the new points, right? And we're going to say model.points. We're going to list reverse. And then we're going to put it on the front. This is really inefficient. It's not, but it is. This is how you do it on the beam. This is probably not the best for JavaScript. But basically, we're rewriting the points such that the position isn't on the last one. And then we're going to say, let's reuse the model. And we're going to say select, let's say points is the field we're going to update. And let's just do that for now. This is not ideal, but we can do something with it, I think. What I also want to do, I think, at this point, at this position is let me put a to-do in here. For now, this only adds points to the model. It does not let you select an existing point in the curve or in the spline. Okay. We have the move selected point though. So we could say right? Oh my goodness. My cat just sneezed on me. Let's do this. Because we're adding it to the end, right? From the original, because, you know, now it's going to be there. And then we've got that. So we haven't changed, and honestly it doesn't matter which order these are in. This, okay, let's just refresh. Did I save? I saved. So it's not going to display anything on the canvas yet because I haven't implemented that, and we should do that next. But let's just, for argument's sake, the other thing I can do, and actually probably better, let's do list append, because it's possible that that is optimized on JavaScript in a way that we can't replicate easily. And that's fine. That's probably just like array append, or there's something better. So we'll see. It's kind of hard to make, you know, the head tail thing work in the same way on JavaScript as it does on Erlang. So let's go with this. I think that's probably the better way to do it. Yeah, it traverses and copies the first list, which is probably not any worse than the reverse and then the reverse back, right? I need a little interactive map in my project, so I got a tad complicated with the pan zooming I need to do. Yeah, I could see that. I mean, we're not doing zoom here, but all right. Let's clear the console. I'm not logging anything, but let's do this. Okay, let me get there. Okay, so our list is falling at the bottom, but we are adding points, right? So these 4 should have been enough to make a curve. And I think that I need, but you can see that it's like, it's not adding them to the top. So what we need to do here, and this is going to throw away all our state, and that's fine, but we need to make this have some minimum width. and let's see what we can get from Tailwind. Sizing, min width. So like, let's do min width 32, and see what that does for our layout. Yeah, the problem is it's I probably need to put flux on each of these things. I forget the norm there. Okay, so now it's actually making its contents flex, and that's not actually what we want. But don't get me to do your, CSS layout. I will fail it. This is not my strength. Okay. What if we did grid instead? The other option is that we do, this is a div, and we put inside it the OL, and that way that thing is not sorry, I'm trying to get this aligned so that it's correct. And that way it's not, the OL is not the thing being the flex item. I don't think that that's going to fix it, but I kind of want to see. Right, so we could say, oh wait, this is the problem. I use flux column here, I want to use flux row. Derp. All right. There we go. So now it's displaying down the right, as I would expect. Okay. Oh, all right. Okay, so if we have, let's refresh this. I want to see if I've got the mouse down. You can't see it. So our move selected point does not work. Here's another thing. We need to reset the spline when we add a point. That doesn't affect anything else, but we should have, this is selected, right? So let's just throw in there a console debug of the model. It is not being called. The other thing, here's the problem. Here's the problem. We're not actually recording that the mouse went down. So in our pick function, we need to add that. Okay, and then it should work. Right? And it's, you know, we need to get rid of that console debug now. Okay, so easy enough. And you can see as we get close to the center of our screen, or the center of our canvas, it's working correctly. These are both positive up here. Good stuff. Okay. All right, let's get to drawing. So again, Tiramisu no longer has these debug lines that we're using in the other demo. Sad time. But let's see what we can do. I think that we can make a combination of using Saviorti directly with some materials. Like we can use the line basic material, it's fine, right? You can create an extension for lines. Yeah. So let's have a look at that and see what we need to do. Yeah, I don't want to have to, but here we are. So this is looking at an old version of Tiramisu. Let's look at main, right? Fine, I know it's not there. Gosh, so picky. Okay. So the built-in extensions. So there are these functions here, right? Primitives. Let's look at how the primitives are. And there should be a ext. Yeah. Okay, so we need observed attributes. Make a node extension. This is complicated, man. Okay, create takes a runtime. I'm guessing that's a Saviorti runtime. Yeah, this is complicated. All right, let's go ahead and make a new module in here, because we're gonna want points as well as lines. So let's make a folder. Lines. Just call it line. Yeah, that would be very, very helpful. Okay, so we're going to import Tiramisu dev extension. And then we're going to make something like this, right? Oh, I'm on an old version, aren't I? Oh wait, yeah. Okay, so we want to have different observed attributes. You're not in the correct. I know. Let's switch to the SHA that I'm at, or we can update. Difference is minimal though. Okay, well let's go ahead and update to whatever this commit is, and we'll just. I think the API for the other things is not going to change, so we'll update to this one. Why you gotta be like that? Okay. And it's gonna break. Yeah, and honestly, let's just say this is. We're gonna comment this out and say to do. Yes, I know. Stop complaining at me. Wow. Tick moved from scene Tiramisu to scene on tick. Okay, that's not hard to change. show me the problem. Okay. We're not using quaternion. We're not using B-splines. We don't have these things yet. That's fine. We're not using vec3s yet. So here, there's no tick subscribe anymore? All right. I probably needed a good Gleam update. Ah, this problem again. It's an attribute now seen on tick. Oh, okay, so I don't subscribe here. Okay, here, stop. Restart the server. It can't find this. That's the problem. Why could it not? Build packages should be there. Oh. Well, why don't I add it? And that will resolve that issue. I'll add it as a dependency. So, whatever version this is referring to. Let's just do that. Yeah, okay. We'll rm manifest. And then interesting. Okay, let me go. This is probably, that's even the wrong ref. Copy. Let's try that. Gleam clean. Deps download. Okay. It's going to complain about the to-do. That's fine. Okay, now I've got the problem that is correct. Okay, unknown module, tiramisu tick. All right, well, let's just go with... Does it still give the delta things there? Yay, okay. So we've got progress. Is this scene.tick context? Scene.tick. Okay, there we go. It's not tick context anymore. And we can get rid of that. And we just put that on our main scene, right? On tick. Okay. Cool. Yeah, I like that better, actually, because it's more sort of like an event handler type of thing. All right. Okay, so to do, that's fine. Yeah, I don't care about unused modules right now. All right. So the thing that we want to have on here is now you have to tiramisu renderer as your parent of your tiramisu scene. Okay, let's do that. And is the renderer the thing that creates the canvas now? Whoa. Hmm. Oh, I actually just need this one. Yeah. Okay. So do I need to put this on the renderer and the pointer events on the renderer? I think so, right? Yeah. Okay. That makes more sense. Oh, something is wrong in here. It's not formatting. I've got too much going on. Let's try to fix these things. Put those up there. Okay, we need that. Now, what's wrong? Okay, so renderer. Just need an ID for it, I guess. We'll just call it renderer. I don't really have any. List of attributes, list of elements. Canvas, render loop, and runtime state for exactly one nested tiramisu scene. Practice render, okay. Yeah. All right, let's see if we're good there. Okay. So I actually think what I want to do here is let's first of all make sure that everything else is working. And I'm going to comment this out so it'll actually build. Make sure we're up to date on that. Okay. Okay, our stuff still works. Not bad. Okay. Even alias called render.width and height. Okay. So like that's it's not a luster attribute is, oh, okay. So I mean, it's basically the same thing. Yep, okay. I kind of like that it says renderer rather than just attribute. Okay. Do. All right, so we need to be able to draw lines, which means we need to create an element. So let's look at how those primitives are added. And we are on main. Okay. So, or we can look at what this extension thing is. Okay, wrap a mutation as a runtime action. Check the first the empty. Okay. Empty. So what does empty do? Okay, for group nodes, right. So you have a tag. Okay. Hide or show the group and its descendants. We don't actually care about that, but okay. Scene visibility rather than the DOM layout. Okay. So create takes a runtime and ID, parent ID, and attributes. Okay, and then you're doing the business with calling Saviority from there. Okay, and then this extension reads attributes. let's look at what these functions do in a minute. Okay, so then on update, it's an option of an object 3D is a Savoiardi object 3D. Yeah, okay. Okay, extension has changed. So you get, this is sort of the web component callback, right? My attributes changed. And this just potentially sets hidden, right? Remove, you remove the object. Okay, so this, let's stub these things out. So we need a tag name, and we'll call this Tiramisu line, for lack of a better word. Okay, and we don't care about hidden, but we need an attribute, right? That we can use. And I think it's let's look at what is that in Luster. So if we go to Luster attribute, like hidden is one that it's just a function. I don't know that we need to do that yet. Is there a custom attribute? Or is attribute just an open thing? Okay, so we property, so we use property. Yeah. You can create an attribute function, attribute.attribute. Okay. Right, I think I want property though, because that lets us put that can be rendered. Those are like properties on the DOM node that aren't part of the rendered DOM. Yeah, anyway, let's think about that. I think we need attributes, so if you have any guidance about putting bits in line that are structured, I would love to see that. I mean, I get the problem is I don't want to be like parsing all the freaking time. And I guess that might mean that we need the JSON. And we do toString on it. Don't like that very much. Because then we need to pull it back out when we go to do things. I guess it's just the life that we live now. Because there's no... Okay. So looking back at the Tiramisu source, let's try to focus here. I was getting a little bit upset. Forget that. Let's make a create function. Okay, so we need to import this, right? Okay, and then we need a create function. And here I'm just going to copy pasta and we will remove things we don't care about, right? Okay. I know I'm lazy, like, so? I'm not creating a group here. We need to import Saviardi, and it's probably going to go, bro, you need that as a dependence, a direct dependency. Yeah. So we're going to throw that in there. Can I do star? Like, I don't care. No, it doesn't like that. We'll copy the one from the tiramisu depths. That's fine. It's fine. We're all fine. Okay. Catch me outside. How about that? Okay. So we need to get... All right. We need to get these things in there as well. And then we will... Okay, so we don't have set hidden. Don't care about that. We need to look at what this object is in Savoiardi. And I think what we care about is the geometry and the material, right? Yeah, I'm just going to do effect none, right? Okay, so let's go to the runtime. So there's a scene, CID, 3D, active camera, objects. Okay. We don't call new runtime. We can get the scene. Okay, so we're gonna have to add an object. So where are the references to this? Add scene, remove scene, clone object, create group, create mesh. We might be doing this. Yeah, create a mesh. It says it takes geometry and material, but it only takes geometry. Okay. Now we could use this create line segments thing. That's probably what we actually want for our object, right? Okay. So going back here, we're going to do something like our object is going to be create line segments, right? And we need to pass it. So we need to get the attributes out, right? For now, let us do this and just say runtime, and then we don't care about not using that. Okay, let's stub our update function here. Okay, our update function has to take a runtime, return a runtime, and we'll just say context effect.none. And here's where we would update the object or remove it or whatever. Okay, and remove is probably going to be the same as that thing. Yep. Okay, it's just saying it's never used. Okay, so now we can do our extension. Okay, so we're going to say this is a node extension for line segments. Okay, so what we're going to do is we care about from, to, and color. right? Because that'll make us change the material or the endpoints of the geometry. Okay, so there's our extension. Now we need to actually make it do something. So let's look at, say, for example, mesh. This is going to be a problem, but that's okay. So here, okay, we can make so these are messages. We don't actually care about those, but we do care about creating. So let's do pub fun from, and this is going to take and I think here what we're going to do is let's make it as easy as possible. So we're going to make attribute dot attribute what is it? Why is this hard? Why doesn't it show up? Okay, and we're going to say float to string p.x, put a space between it, p.y. Okay, so that will be straightforward enough to parse. Okay, and then we're going to do the same with 2. And this is going to be 2. Straightforward, nice. Like, I don't want to overcomplicate it. I do want this to like look like you can read it in the HTML that's produced. So, okay. And then we're going to make color, and this is going to be an int, and is there already a color one? No. Color space? That's not what we care about. Okay, so we'll just say attribute color, and we're going to say int to base 16 of C. Okay, so now we've got our attributes, and those are the same as from, to, and color. Okay. Now I should probably make this vec3f because that's going to be what goes into the into the geometry definition, right? I'm wondering though, Okay, so we would do something like this. Create a buffer attribute. This is a little complicated. And then we would set it on the geometry. I think that that's the way to go. Like, we were looking at the old version of Tiramisu, and it was doing some stuff in JavaScript for that, creating the lines. I think that that's probably... The other thing that we can do here is I want to be able to use the line width in the material. So we say pub const width attribute dot width, and then we'll make the observe attributes width. Let me check how it should be done, because that's overcomplicated. Yeah, I mean, it was like you would create the geometry from the list of points, and there's only 2. So I think this actually needs to be, yeah, let's go ahead and change this to vec3f, because okay. Mess that up. Okay. Okay. Create. So we should have a material, right? Let's do that first. And the color, we need to get the and we'll make this little function here for us. Make this down at the bottom. It's a little utility function. And I think that we should, have it return a default on these. That way we can get and a float. Okay. So the dictionary module. Yeah, we'll just do get. Okay, so we're going to say let color is get from attributes color. Okay. C, and then we're going to do int, or is it int base parse? You know, this is probably better as a result try or result map followed by an unwrap. Excuse me. So let's make a block here and say use C string is get attributes color. And this is going to be result map. And then we're going to say int result.map int to base string. No, not to base string. Int base parse. Yeah, there we go. 16. And then we can do result unwrap. And we'll just unwrap it to 0. Yeah, I know. To do. Oh, this is result try. Okay. So color comes out in int. And we'll do the same for the width. So let's do let width width stir is result.try dict get attributes width. And we want a float here. We'll just say W result.map float.parse W stir W. And then result unwrap. And let's just say 1.0 is the default. So color width. Okay, not too bad. So those are the material attributes. And so let's create the line material takes the color and the width. Not too bad. Let me check how it should be done because it's overcomplicated. Yeah. Okay, so now we need to be able to create this line segments thing. I was pretty sure that that was in there. Create line segments. Okay, so here's, it takes a geometry and a material. So we need to construct our geometry. Every pair of consecutive vertices forms a separate line segment. So this is interesting in that maybe what we could do is put all the points in one line. And I think that that's what we want. So this is not from and to. Let's extract a function for that. We'll call this point to string. Oops. Yeah, that didn't work. Point to string, please. You should be doing F and A instead of relying on Saviardi for this. Okay. I mean, I can do that. What? How? That's what the problem is. Okay. Yeah, and this is... Okay, we're not going to keep these around, though. I just wanted to extract that because we're going to map over these things. Yeah, it's fine. Yeah, I don't mind doing some FFI here. The thing is, though, like, we can create a buffer geometry and do this. Like, this isn't so bad, right? Okay, so let's abort from. We're not going to expose from. Let's say points is going to be a list of vec3f. Okay. And we're going to maybe what we do is this is a string tree. Because we can use not that. We can use string tree to do join, right? So let's do from strings. It's not actually what I want. I want string here, string tree join, and we're going to use spaces. And here we're going to do okay. This is just a better way to build these things up, right? And we're going to get rid of that function, and we're going to get rid of the to function as well, because we're not tracking that. So let's go down to points. Not to points. We need to add this as the attribute we care about. The observed attribute. Okay. So we're going to take P and we're going to list map point to string, right? And then we're going to do, we're almost running out of time, join those with commas. Should be safe. And then we're going to go string tree dot toString. Okay, we need to import list. Okay, so really we're kind of flattening this into. Now, honestly, I should probably do this differently. This would be more like, if I do space here and comma here, that's more like SVG, which might be useful for folks. Okay. And that'll just make a lot more sense, I think. Okay, so if we do that, then in our create here, so we've got a material. We're going to say geometry. So we need to get the points out of the attributes, right? And this should return a list of vec3f, vec3f. Okay. That's good enough for now. So if we do let me think about this. The issue is we're going to have to parse this, right? So let's, and we need to make sure that they're in groups of 3. That's not what we want. It's window, not sliding window. Sized chunk. Okay, we can do that. Copy the implementation of the transform module. All right, well, let's look at the transform module real quick. Position, scale, rotation. Yep. I mean, that's sort of what I did. Okay, so we do like this sort of bit. Okay. That's interesting, yeah. There's a parse transform. Vector to numbers. Oh, extension parse number? That's a thing? Okay. Yeah, we can grab this. Well, here's a get an attribute with a parse function. That's pretty useful. There's parse number. Okay. Yeah, those are both useful. Yeah. So this get is actually something that we could take advantage of. Um, so let's rethink this real quick so that we can reframe it, and then I think I need to stop for the day. Because I'm personally running out of steam, but also we took on a lot more complexity than I expected. So we're going to get from attributes color, and this has a default. We're going to say of 0, and then we can do this. Because this takes a callback, right? In the last one, the parse function. And this parse function is so let's comment that out and see what we got. Yeah, so that comes out correctly as an int. That looks pretty nice. Let's do the same for, honestly, this is, we can use parse number on there. So gain extension dot get attributes with 1.0 extension dot parse number. Easy peasy. That was a nice cleanup. The other thing that we could do here is, instead of this business, we could say, we can inline that and just do like so, and no use. Nice, right? Oh, we need 0 as the default. Yeah. Okay. Okay, let's go back to, as you said, in the transform. Okay. Cool. Yeah, that feels a lot better. Thank you for having me look there, and I can. Okay, so we could do. So there's parse vector. List of float, vector to numbers. No. That's more like string to numbers. Okay, so yeah, we can do this. This is good. Yeah, let's grab this out, because we're gonna want to do that on substrings, right? And import Gleam string. Okay. And we can do this. Let's get that one, because we're going to want that. Fine, import that. Okay. So now I need except I did it with comma, right? And I think that I need number list to, or we'll call it point list to vectors. And we'll follow some of the same pattern. We'll say result list of vec3 vec3f. I really love those type aliases. I know, like, I'm bad, but it's okay. All right, that's just a string, right? So it is a string split, but then we want to map over the contained list. So so we'll say points. Oops, points. String split on space list map of vector to numbers, and then that is, we need result.all to flatten it, and then we need list map actually we need sort of a compose here. That would be better. Let's do it this way. Parse vector and result.all. This is the dumb way, right? So okay. So string split returns a list of strings. List map over that list of strings, vector to numbers. That returns, so this what did you do here? What is the output of this? A list of result of list of float, right? So result all okay. And then we map, yes, I'm aware it doesn't fit. What is the output of this? Oh, okay, so then we need to, this is result map. So this might need a use to make sense. Okay, so now we've got, this is getting bonkers. Yeah, I don't think we can do this with a straight pipeline because each of these things is returning result. And then you have lists of results in some cases. So, let's say, let's call it list of points. And then we want to do actually we want to do this. Running out of variable names here, folks. Okay. So this is a list of floats. There's a bit of like, maybe we should use try. Yeah, we should use try because we only really care about the I'm getting my brain in a twist. Yeah, do or do not. There is no try. I'm definitely getting my brain in a twist, and I think that means it's time to stop. So we'll resume this next time. I may just resolve this off stream when I can think more clearly. But like here we have a string. Here we have a list of strings. Here we have a list of result of list of float. No. And here we're going to have a result of list of float. So that's what that transformation does. Our next step is we want to take this and map it into vectors. Yeah. All right. Next time. Thank you for hanging out, and we'll get this figured out. Cheers. Have a good one.